Hey, hello to all my fans and supporters. This is Mr. Math Guy. So today we're doing some higher degree factoring. So for the do now, I want you guys to do A, B, and C. Just pause the video and play it once you're done. So this is what you should get for A and B. A, do the AC method, factor by grouping. Make sure you see this negative 4x. That's the first term, that second grouping. Make sure it's negative, so yeah, make sure you take out a negative 4, not just take out a 4. So there's A and B. Oh my gosh, look at C. How is C different than all the questions we have been doing? We have a degree 3. Oh no, that doesn't really change too much, because how is it similar? How is it also similar to questions we've been doing? Most notably looking at B. B has 1, 2, 3, 4 terms, and C also has 1, 2, 3, 4 terms. So we could do the same exact method if it is factorable. So for when we have a cubic polynomial with 4 terms, we could do the same thing we've been doing. Just do factor by grouping. So take the first 2, take out the GCF there, it'd be x squared. Then we have x plus 2. And take out the GCF of the second 2, so that would be negative 9. We're left with x plus 2. Awesome, look at that. We got the same thing. We have the same common factor there. I know we can take that out, so that would be x plus 2. And what's left over is x squared minus 9. Oops, before you go circling that answer, check to see if we can simplify that anymore. Can we further factor this? X squared minus 9 is a difference of 2 perfect squares. So the x plus 2 stays, and then the x squared minus 9 could be x plus 3, x minus 3. And that is our final fully factored form. Let's go to the next page. Looking at the next page, we have a very similar one to what we just did on the do now. So we have, it's degree 3. We have 4 terms. We want to try and do like the ways we know how to factor. So maybe we could try factor by grouping. But first, what's the very first thing you should always think of for factoring, no matter what you're doing? No matter what type of factoring, always look for the GCF first. So I'm going to look for a GCF. They don't share, everyone thinks have an x, but they all are even, so I can take out a 2. And what I'm left over is x to the third plus 3x squared plus 5x plus 15. And you could be asking, Mr. Math Guy, do I need to take out the GCF there first? Technically, you don't need to. You would just need to do it at the end. I find it's difficult to see the GCF if I don't do it first. So I always take out the GCF first, and it makes the question easier as well if you do take out the GCF first. So we can factor the first 2 and the second 2 now. Make sure you keep that 2 out in front. We take out GCF of x for the squared for the first 2. We're left with x plus 3. And then we take out a GCF of 5 for the next one. We're left with x plus 3 as well. Look at that. We got the same factor there, so we know we're going to be correct. We got x, we got 2. We got the x squared plus 5. And then we got the x plus 3. Before you circle that, anything I could simplify? No, that's it. So that is our answer. I just want you guys to do the next, just do that next one. And this is what you should get. Be careful. Make sure if you take out the GCF first, a common mistake I see is that some people tend to forget it in their answer at the end. So just make sure you factor out that GCF in the beginning. Keep it throughout the entire question. Let's go to the next page. So I just want you guys to do the checkpoint. Pause the video. Play it once you're done, and we'll go over. So here's what I got for the first 2. That second one, make sure you completely factor it. So we have x squared minus 25. That's the difference of two perfect squares. We can continue factoring there. And then how is factoring a cubic polynomial with 4 terms similar to factoring a trinomial of the form ax squared plus bx plus c when a is greater than 1? And all those lines, just to say they both involve factor by grouping. Woo! That's all you gotta say. You don't need to fill up all those lines if you don't want to. So let's go to the next page. So wow, look at that, a second do now of the notes. You know it's going to be a good notes packet when there's two do nows. So I just want you guys to pause the video, do now A through, that's the next 6 questions, and play it once you're done. So here's what you should have gotten. Anyone notice anything about this other than they're pretty much the same numbers? Think about what we're always ending with a minus 24, which is a constant. And then look at the degrees of the first term and the second term in standard form. So the degree here is 2. The degree here is 1. Degree of the first term is 4. Degree of the second term is 2. Let's look at D. The degree of the first term is 100. Degree of the second term is 50. What's always happening with these degrees? The highest degree is always double the second highest degree. So that's what we're going to be doing today for the second part of the notes. Let's go on to the next page. On the next page, so factoring higher degree polynomials, notice when the highest degree is double the second highest degree, and we are adding a constant. Everything pretty much the same exact thing as we have been doing. So it's not even like you're learning something too new today. So if you look at the first one, we have x to the fourth and x squared. Okay, x to the fourth is double the degree of x squared, and we're subtracting a constant. So we can do our factor by grouping, or if you notice, our lead coefficient is 1. So we could say what two numbers multiply to negative 42 and add to negative 19. If you were thinking negative 21 and 2, you are correct. So that would be x squared minus 21 and x squared plus 2. Any difference of two perfect squares there? Nope, we're good. Circle it. Keep moving. On the next one, you guys can pause the video and play and do the next 3 if you want to. I'll talk through the next 3 as well, so you can play it once you're done if you do want to do that. All right. First degree is double the second degree, and we're adding a constant. Perfect. I can just keep on factoring like we have been. So the two numbers that would multiply to 32 and add to negative 18 would be negative 16 and negative 2. Lead coefficient's 1. Perfect. So that would be, it's x to the 20th, so that would make this x to the 10th minus 16 and x to the 10th minus 2. If you guys want to do factor by grouping for this, go right ahead. You can. But don't circle this yet, because we do have a difference of two perfect squares. X to the 10th, any even exponent is going to be a perfect square. 16 is a perfect square, and we're subtracting. So we can write this as x to the 5th plus 4, x to the 5th minus 4, and then x to the 10th minus 2. 2 is not a perfect square, unfortunately. Is this our final answer? X to the 5th is not a perfect square. Like I said before, it's not an even exponent. So that is our final factored form. The next one, 7x to the 8th plus 18x to the 4th plus 8. We do have the first term is double degree. This is the second term, and we're adding a constant. So we can factor this, but we have a lead coefficient that's 7. So we need two numbers that multiply to 56, the 7 times 8, and add to 18. If you were thinking 14 and 4, you would be correct. So the only difference here is we have that 7x to the 8th. We have that plus 8. What we do with the 14 and the 4 is we split up that 18x to the 4th. So we have a plus 14x to the 4th plus 4x to the 4th. When you add those two back up, you get 18x to the 4th. So we're really not changing anything. So now we could just do our factor by grouping. We're just rewriting the question, so we can do factor by grouping. Take out GCF for the first two. That'd be 7x to the 4th. We're left with x to the 4th plus 2. And then take out GCF for the second two. It looks like it's going to be a 4. So that'd be x to the 4th plus 2. Look at that. We got the same thing inside of those parentheses. So we take it out. X to the 4th plus 2. And what we're left with is 7x to the 4th plus 4. Can I factor that in the board? No. Circle that is our answer. And the last one. All right, two numbers that multiply to negative 10 and add to negative 3. Wait. Why don't I need to even do that? Look at those. We are adding or subtracting a constant, but our highest degree is 24. Our lowest our second highest degree is 10. 24 isn't double of 10. So we cannot factor this the way we have been doing. So we can just write 2x to the 24th minus 3x to the 10th minus 5. Circle that's our answer. Or you can just say it's also not factorable. That's a tricky one. So let's go to the next page. On this page, so what's a little bit different about the ones we're trying to factor right now? Look at those exponents. Our exponents also have a variable in them. So it's actually not even going to change that much of what we do. If we still look at it, we're adding a constant at the end. The two other terms, if you look at, we're going to zoom in on this one. We have, this has a degree of 2a. This has a degree of a. So 2a is double a. So this is the way we can keep on factoring it. So Lie coefficients 1, let's just do two numbers that multiply to that last number. Add to the coefficient on the second term, which would be negative 2. That would be negative 1 and negative 1. Okay, so we have our two numbers we want it to be. And now, so think about it if it was just x squared. I know this is not it. If it was x squared minus 2x plus 1, we would just take that degree of the x, which is just x to the first, x and x right there, minus 1, minus 1. But that's not the case here. That is an a, x to the a. So all we do is it's x to the a minus 1 and x to the a minus 1. So this is just x to the a minus 1 times x to the a minus 1. Now that I look at this, make sure that a doesn't look like a 9. That looked like a 9 right there. So, and that would be our answer. And if you're like, oh, I don't know, like if you're doing this like on a test or something like that, like, oh, I don't know if that's correct, we could always check our work. So always just multiply it out. Multiply everything by everything. So x to the a times x to the a. And then we have minus 1 times x to the a. We also have minus 1 times x to the a. And then we have negative 1 times negative 1, just plus 1. So this is where you might get a little confused. X to the a times x to the a. Well, think about back to 8th grade or the beginning of the year. What do we do when we're multiplying with the same base? You add the exponents. So we're going to add a, and we get a plus a is 2a. So x to the 2a, these are like terms. Add them together. Minus 2xa plus 1. Voila. We get back to the original expression. And if you want to pause the video and do the next 3, go right ahead. I'm also going to walk through them. So if I look here, at the next one. First thing I should do, okay, I'm looking at, we got that constant. This degree is double that degree. We're good. But always the first thing you should do is look for a GCF. So here, they're all even. I can take out a 2. So when I take out a 2, I'm left with 3m to 2x plus 4mx minus 32. And now I could try my, okay, two numbers. We got the Lie coefficient is 3. So we need two numbers that multiply to 3 times negative 32, which is negative 96. Add to 4. Try a bunch of numbers out. Try 2's not going to work. And it's not going to add to 4. I think we can use 12 and negative 8. So keep that GCF out there. We are now have 3m to 2x. Now we can put the negative 8 first. We can put the 12 first. I'm just going to put the 12 first. So it'll be plus 12. And make sure you put that the correct variable with that. It would be m to the x. Because we're splitting up that, we're splitting up that 4m to the x in this case. Minus 8m to the x minus 32. We do our factor by grouping, first 2 terms, second 2 terms. So don't forget GCF out in front. Take out a GCF of 3. And what else does it share? Well, it's m to the 2x and m to the x. So it also is 3m to the x. And what's left over is just an m to the x here, plus 4. And if you're like, oh, how did you get that m to the x there? Remember, when we're factoring out, we're just really dividing. So if you divide this by 3m to the x, 3's are gone. And then m to the 2x over m to the x. Think about our exponent rules. When we're dividing, we subtract the exponents. 2x minus x is just x. So that's why it'd be m to the x. But let's get back to our problem. So then we would take out our GCF of 8. That'd be m to the x plus 4. Look at that. We have that same term right there. So we can factor that out. Make sure that GCF out in front. We got m to the x plus 4. And what's left over is 3m to the x minus 8. No difference, 2 perfect squares there. That's our answer. And for the last two, look at that. First term, remember that degree, if it's just an x is a 1, the first degree is double the second degree. And we're adding a constant after that. So we could do our way of factoring. The Lie coefficient is 1, so we just need two numbers that multiply at 12. Add to negative 8. That would be negative 6 and negative 2. So we can just take that middle term and make it x to the 1/2. X to the 1/2 minus 6 minus 2. You can circle that as your answer, but we usually don't like using fractional exponents in our final answer. So what I would do is I would write the square root of x and the square root of x. So square root of x minus 6 and the square root of x minus 2. And that last one, oh my gosh, that first degree is not double the second degree. This is not going to be factorable the way we are able to do it right now. So we're just going to say it's not factorable. That we could also say that is our answer. So on the last page, I just want you guys to do the checkpoint. Pause the video, play it once you're done. Here's what you should get for the checkpoint. Make sure, I feel like the biggest thing for the checkpoint are these ones with the exponents being a variable. Make sure you're good with those, especially D. That one had a Lie coefficient that wasn't 1, so it makes that a little bit more difficult. But that's it. You got the success criteria and the homework /practice after this.